The blistering Egyptian sun pounded relentlessly on Al Karim airstrip in July 1942. But squadron leader Marcus Hale wasn't fazed by the sweltering heat. His real concern loomed at 22,000 feet. Up there, in the thin, oxygen-starved air where engines struggled to breathe, Nazi Mi-109G interceptors dominated the domain. The Spitfire Mark V, once the unchallenged hero of the Battle of Britain, was now being embarrassingly eclipsed in the one factor that spelled life or death: altitude. The data laid out a harsh reality. A Messerschmitt Mi-109G2 could rocket to 20,000 feet in roughly 7 minutes and 45 seconds. The Spitfire Mark V? It slogged through the same climb in nearly 9.5 minutes. 2.5 minutes might sound insignificant until you're the one strapped in the cockpit, staring up as enemy planes circle 3,500 feet above, turning their height into a killer advantage, the power to dive, unleash hell, and zoom away before you could even line up a shot. The Luftwaffe called it hit and run, and it was carving through Allied pilots across the Sahara like a scythe. Group Captain Elias Thorne captured the frustration in his battle logs from 258 Wing. His men were constantly tangling with Mi-109s that simply pulled up and vanished into the heights when things got dicey. British fighters would grind upward. Rolls-Royce Merlin, 46 engines pushing hard, superchargers wailing in protest, while the Axis pilots casually tacked on another 1,500 feet and hovered like predators. The math of combat was brutally clear. Control the altitude, control the fight. And that summer, the Royal Air Force was on the losing end. The Spitfire's max ceiling was around 37,000 feet, but its punch faded fast above 20,000. The Merlin 46 shone at low levels but gasped in the rarefied desert air where most scraps unfolded. Axis aces had clocked this early on. They'd haul ass to 26,000 feet or higher before jumping in, forcing Spitfires to burn fuel and sweat climbing, arriving at the party with overheating engines and pilots already wiped out. Wing Commander Alistair Spike Donovan, at the helm of 714 Squadron, had to bury 4 of his boys after a recon patrol on June 15, 1942. The debriefs from the lucky ones were carbon copies, bushwhacked from above, too slow to climb and counter, left with no choice but to nose down and bug out. Nose down and run, the words stuck in throats like sand. Spitfires were supposed to be the kings of the sky. Yet here they were, ducking fights because their engines couldn't hack the heights. It wasn't for lack of guts or know-how. These RAF lads in the Middle East were battle-hardened, survivors of the Channel brawls and Sicilian hauls. But all the experience in the world didn't matter when physics stacked the deck with a 2,500-foot head start for the enemy. Pilots started begging for transfers back to Europe, where dogfights stayed low and played to the Spitfire's sweet spots. By late 1942, it was a full-blown crisis. Air Marshal Desmond Hartley, boss of the Sahara Air Command, was desperate for a breakthrough. His birds were getting vertically outclassed, and no fancy maneuvers could fix an engine that wouldn't cough up more power up high. The brass channels? Zilch. Rolls-Royce was tinkering with better Merlins, but that was months off the line. His boys needed a miracle yesterday. Little did Hartley know that miracle was brewing in the head of a maintenance whiz about to pull off what Rolls-Royce would brand as engine sacrilege. Sergeant Major Edwin Red Harlan was no engineer by trade. He'd signed on as a rigger, fixing frames, not fiddling with power plants. But the Sahara didn't care about job titles. Out in the sticks, with dust in every crevice and parts shipments taking forever. You learned the whole damn plane or watched good men die from your slip-ups. Harlan had torn down and rebuilt Merlins enough times to know them like his own heartbeat, and that kind of closeness bred bold ideas. It all kicked off with a nagging observation during mid-July inspections. Harlan eyed the manifold pressure gauge oddly. The Merlin 46 topped out at +9 psi, marked by that fat red line pilots were hammered never to cross except in do-or-die moments, and even then, just for a heartbeat. But Harlan had seen these beasts post-battle, pushed way past the line in life-or-death twists, and they hadn't blown apart like the manuals screamed they would. Those books were full of doom and gloom. Exceed the pressure, and you'd get pre-ignition, a wild explosion in the mix that'd smash pistons, split heads, and junk the whole 1/800 horse mill in seconds flat. Words like catastrophic failure and structural annihilation jumped off the pages. Pilots knew that Red Line was the Grim Reaper's doorstep, for the Hun or for you if you got cocky with the stick. Harlan, though, had a grease monkey's skepticism about safety pads. Engineers always pad the numbers, don't they? He muttered to himself one sweltering afternoon, wiping sweat from his brow. They'd test till it broke, then dial back the limit for wear, wonky builds and ham-fisted pilots. Smart, sure. But what if Rolls-Royce had padded too thick? What if the real edge was sharper? The idea chewed at him as he saw Spitfires limp home, pilots fuming over botched scraps. That evening, over stale coffee in the briefing hut, he spilled it to Flight Sergeant Thomas "Tommy" Reed, a lanky vet with a scar across his cheek from a near miss over Malta. "Listen, Tommy," Harlan started, leaning in close, his voice low against the hum of generators outside. "I've been thinking about these Merlins. That red line at +9 psi, it's bogus. I've seen 'em pushed harder in fights, and they hold. No bangs, no bits flying. Rolls-Royce is playing it safe, but out here safe gets you killed." Reed swirled his mug, eyeing Harlan skeptically. "Red, you're talking crazy. The manuals say detonation at anything over. Pistons turn to confetti. And even if you're right, that governor's there for a reason. The throttle stops dead at +9. Can't push past it without hacking the rig." "Exactly," Harlan shot back, his eyes lighting up. "But what if we move the stop? Adjust the relief valve? Give it room for +13 psi. That's 25% more grunt. We could match those 109s in the climb." Reed set his mug down hard, glancing around to make sure no one was eavesdropping. "You're talking court-martial, mate. Tampering with the throttle assembly? Air Ministry'd have our heads. There's protocols, tests, approvals. This ain't some backyard fix." Harlan leaned closer, his voice urgent. "Protocols? Where were they when Spike lost those 4 lads last week? Blasted from above because we couldn't get up there. I've lost count of the funerals, Tommy. If this works, it saves lives. Your life. And if it don't, well, better to try than watch more mates auger in." Reed stared into his coffee, the weight of lost wingmen heavy on him. He'd seen too many good blokes buy it because the Spits couldn't keep up vertically. After a long pause, he looked up, jaw set. "All right, Red, do it to my bird first. AB 728. If she holds together and climbs like you say, we'll talk about the rest. But if she grenades mid-air, I'll haunt you from the grave." Harlan grinned, clapping Reed on the shoulder. "Deal. You'll be thanking me when you're dancing above those Jerrys." Reed omitted the obvious. This wasn't just bending rules. It was snapping them. Modifying controls without sign-off was tribunal bait, but Reed had buried 3 pals in a fortnight to height woes. He'd watched them spiral down, outclimbed and outgunned. Official fixes were vapor. Time for rogue engineering. The Merlin wasn't just machinery. It was a symphony of fury in 12 cylinders. At its core spun a single-stage supercharger, a whirring beast at 28,000 RPM, geared off the crank, shoving air in harder than Mother Nature ever planned. More air, more O2, more fuel, more boom, turning a 27-liter lump into a Yoni 500-horse screamer instead of a 700-horse plotter. Manifold pressure tracked the extra shove over ambient 14.7 psi. At +9, it was cramming 23.7 psi absolute, 60% bonus. But compression heated things up, so an aftercooler chilled the mix. Hot air was thin air, killing the point. Combustion physics set the caps. Smooth burn from the plug, or too much squeeze heat sparked pre-ignition, the whole charge going kaboom at once, spiking pressure to punch holes in parts. That ping sound? Death knell. Fuel was 87 octane early, bumped to 100 for better knock resistance. Rolls-Royce figured +9 safe with wiggle for variables. But real engines varied. Some could take more, but the limit protected the lemons. Heat threw curveballs. A cool run versus desert blaze changed everything. One universal limit for all? Conservative, but necessary. The throttle barrier was a simple stop blocking the lever. Ditch it in 15 minutes. But then every push was a bet on your engine's mood. Harlan waited till the evening patrol was down and crews chowbound. Reed's Mark VB AB 728 cooled in its sandbag nest. The fix was dead simple, almost laughably so. He popped the starboard panel, lamp tracing the linkage. The stop, a wee alloy nub locked with wire. Snip, yank, grind smooth. 7 minutes, but the intake's dump valve was next, set to bleed at pulling 9.5. Deep in the cowls, panels off, careful not to drop bits. 4 turns on the adjuster bumped it to +13 on extra 4 psi, 25% power hike. No telltales unless you poked around. Gauge would show forbidden numbers, but the bird looked stock, till it flew. Risks? Real. Pre-ignition could shred pistons, rods through the case, oil spray, maybe crank snap and prop goodbye. Flames in combat? Game over career-wise? Probe finds your handiwork. Tribunal nails you for wrecking King's property and endangering life. Jail discharge, but Reed signed off. Jerry's scarier than a hot Merlin dawn. Harlan watched Reed strap in for scout. No chatter. If it flew, great. If not, too late. Reed checked gauges extra careful, heart thumping. Come on, girl, he whispered to the dash. Merlin roared alive, taxi normal. Liftoff 0615, climbing turnover Delta waters, safe crash zone. At 4,000, standard climb fine. Then, tentative push past red. Pause 10, steady. Pause 12, smooth. Pause 13, surge like a kick, pinning him. Climb gauge, 3,600 FPM, VERS stock, 2,700. Matching Mark 9 specs, not even in fleet yet. Level at 16,000, tests, higher speeds at Pause 13, heats okay in Morn cool. Battle climb 16K to 21K, 550, VERS. 9 mins 2,500 foot gift. Push to 27K, 15 mins overboost, no hiccups. Bloody hell, Red was right, Reed breathed. Oxygen mask fogging. Descending, spotted axis trails level. Normally skip. Today, Pause 13 and climb. Jerry's bolted, shocked. No chase, proof enough. Landed 0745, taxied to Harlan, who feigned calm. Reed hopped down, grabbed Harlan's arm. Red, you genius bastard. She climbed like a homesick angel. Felt the power. Pushed me back like never before. No shakes, no knocks. We outclimbed what should have been impossible. Harlan's face split in a grin. Told you, the boffins patted it too much. Every damn spit in the squadron, Reed insisted, voice fierce. Tonight, no more losing lads to height. This changes everything. Harlan nodded, serious. We'll do it quiet. Mills, Grayson, trustworthy. Cover. Cable tune-up. Overnight grind. By dawn, July 24th, 18 birds tweaked. Briefing whispers at Brecky. Push past red. Trust it. Motor'll hold. Days logs. Epic. Jeffrey Lang outclimbed 109 at 25K. Jerry tried to zoom away, but I was right on him gaining. Shot him down clean. Samuel Brent. Matched escape to 29K. He looked back, shocked as hell. My spit was a rocket. Axis aces, comfy up high, now had spits above, diving in. Rumors flew. By July end, 732 squadron techs snooping. Heard your climbs are mad. What's the secret? Harlan stonewalled, but pilots blabbed over pints. Our Merlin's got extra kick. Push plus 13, no sweat. Soon, 732 tweaked. Then 518, 395. Epidemic.tech chiefs chose rules or lives. Lives won. Wing Commander Victor Slade sniffed it mid-August. Uniform climb stats. Summoned chiefs. Spill it. They did. Throttle stops gone. Valves adjusted. Pose 13 PC. Works, sir. Losses down, Slade pondered. Can't approve, but won't stop. No reports up. Keep it mum. Not all flexible. Maruba's Leonard Frost found tweaks. Barked. Reverse now. This is madness. Texted. Daylight. Night. Redid. Flyers. Still flies great, sir. Frost. Must be imagination. HQ clueless till September. Logs better? Tactics, they said. Then, tweaked bird quits over Crete. Safe land. Inspect. Tweaks obvious. Memo storm. Reverse all. Tribunals. Ignored. Received. Then nada to Air Vice Marshal Gordon Hale. Ban orders versus lower losses. Needs time, he stalled. Probe team, Robert Kane arrives October. Show me damage. None. 14. Merlin's, 250 plus hours at Pleasant 13. Normal wear. Impossible, Kane muttered. But data said otherwise. Interviews. Manage mix, short bursts. Cool morns help. Report OKT 20, diplomatic. Breaches yes, but works. Test properly. Firestorm, Rolls-Royce, bypasses safety. Ministry, undermines authority. But William Baxter, we're winning heights now. November deal, no approval, but no chases. Crisis thrust cover, Rolls-Royce tests, deck plus 13 holds, if smart. March 1943, new specs, plus 13 steady, plus 17 emergency, illicit now official, Merlin 70 and Mark VIII. Built for it, PUDS 1926, techs reshaped understanding. New protocols, field ideas tested. Harlan, no glory. Ended war sergeant, fixed autos Yorkshire, sparse war tales. Reed, 14 kills, medal. Memoirs, tweaks saved me 4 times. Outclimbed doom. Post-war, flexible limits, feedback loops. Jets today, overrideable modes from that Egyptian hack. Spitz at Al Mansour 42 climbed on phantom pressures, trusting wrenches over books. Wrench 1. Changes made. The Libyan sun hammered down on Gambert Airfield in June 1942. But it wasn't the heat that worried Flight Lieutenant Neville Duke. It was what waited at 22,000 phi. Up there, where the air thinned and engines gasped for oxygen, German Bf-109F fighters owned the sky. The Spitfire MV that had dominated the Battle of Britain now found themselves embarrassingly outmatched in a dimension that decided who lived and who died. Altitude. The numbers told a brutal story. A Messerschmitt Bf-109F4 could climb to 20,000 ft in roughly 7 and 12 minutes. The Spitfire MKV took nearly 9 minutes to reach the same height. 2 minutes doesn't sound like much until you're the pilot watching enemy. Fighters position themselves 3,000 ft above you, converting altitude into the most lethal advantage in aerial combat, the ability to dive, attack, and climb away before you can even react. The Germans called it boom and zoom, and it was slaughtering RAF pilots over North Africa. Wing Commander Ian Glee documented the problem in his combat reports from 244 Wing. His pilots repeatedly engaged Bf-109s that simply climbed out of reach when the fight turned against them. British fighters would labor upwards, their Rolls-Royce Merlin 45 engines straining, superchargers howling, whilst German pilots casually gained another 1,000 ft and circled like hawks. The tactical mathematics was simple and deadly. Whoever controlled the altitude controlled the engagement. And in the summer of 1942, that wasn't the RAF. The Spitfire's service ceiling sat at approximately 36,500 ft, but combat effectiveness dropped off dramatically above 20,000 ft. The Merlin 45 engine, magnificent at lower altitudes, struggled in the thin air where desert combat actually occurred. German pilots had worked this out quickly. They'd climb to 25,000 ft or higher before engaging, forcing Spitfires to burn precious fuel and time clawing upwards, arriving at combat altitude with overheated engines and pilots already exhausted from the climb. Squadron leader Brendan Paddy Finucane, commanding 602 Squadron, watched 3 of his pilots fail to return from a patrol on 12th of June 1942. The combat reports from those who survived told the same story. Ambushed from above, unable to climb fast enough to counter, forced to dive away and disengage. Dive away. The words tasted like defeat. Spitfires were supposed to be the finest fighters in the world. Yet here they were running from a fight because their engines couldn't deliver the performance needed at operational altitudes. The problem wasn't courage or skill. RAF pilots in North Africa were among the most experienced in the world, many veterans of the Battle of Britain and the Malta convoys. But experience meant nothing when physics and engineering put you at a 2,000 ft disadvantage before the first shot was fired. Pilots began requesting transfers back to European operations, where combat occurred at lower altitudes, and the Spitfire's characteristics played to their strengths. By mid-1942, the situation had reached crisis point. Air Vice Marshal Arthur Cunningham, commanding the Desert Air Force, needed a solution. His fighters were being systematically outperformed in the vertical dimension, and no amount of tactical cleverness could overcome an engine that simply wouldn't deliver more power at altitude. The official channels offered nothing. Rolls-Royce was already working on improved Merlin variants, but those were months away from production. His pilots needed help now, not next year. What Cunningham didn't know was that the solution was already taking shape in the mind of a ground crew mechanic who was about to commit what Rolls-Royce would consider technical heresy. Flight Sergeant Henry Ginger Lacey wasn't supposed to be an engineer. He'd trained as a fitter, which meant his job was maintaining airframes, note engines. But North Africa had a way of blurring those distinctions. When you were stationed at a forward air base with sand and everything, and replacement parts measured, in weeks rather than days, you learned every system on a Spitfire, or you watched pilots die because of your ignorance. Lacey had stripped and rebuilt Merlin engines often enough to know them intimately, and intimacy bred a dangerous kind of confidence. It started with an observation that wouldn't leave him alone. During pre-flight checks in early July 1942, Lacey noticed something peculiar about the boost pressure gauge. The Merlin 45 was rated for a maximum of 29 per square in of boost pressure, marked with a thick red line that pilots were trained never to exceed except in dire emergencies, and then only for seconds. But Lacey had seen these engines after combat sorties. He'd seen them pushed past limits in desperate dogfights, and they didn't disintegrate the way Rolls-Royce's technical manuals promised they would. The manuals were explicit and terrifying in their warnings. Exceeding boost pressure would cause detonation. Uncontrolled explosion of the fuel-air mixture that would destroy pistons, crack cylinder heads, and turn a 2,000 tunnel of engine into scrap metal in seconds. The technical documentation used words like catastrophic failure and immediate structural damage. Every pilot knew that red line represented the boundary between life and death, not just for the enemy, but for yourself. Your own engine could kill you if you got greedy with the throttle. But Lacey had a mechanic's suspicion of safety margins. Engineers always built in buffers, didn't they? They'd test an engine to destruction, find it failed at some threshold, then set the operational limit well below that point to account for wear, manufacturing variations, and pilot error. It was sensible engineering. But what if Rolls-Royce had been too cautious? What if the real limit was higher than the official one? The question nagged at him whilst he watched Spitfires return from patrol, their pilots frustrated and their combats ineffective. He shared his theory with Flight Lieutenant James Johnny Walker over lukewarm tea and the dispersal 10-tone evening. Walker listened, then pointed out the obvious problem. Even if Lacey was right, even if the engines could handle more boost, there was a mechanical governor that prevented pilots from accessing it. The throttle assembly included a physical gate that stopped forward movement before boost pressure could exceed plunger 9 psi. It was a fail-safe built into the aircraft itself, impossible to override accidentally. You'd have to deliberately modify the throttle mechanism to access higher boost settings. Walker left unsaid what they both understood. Modifying a throttle assembly without authorization wasn't just against regulations. It was the sort of offense that ended with court-martial. The Air Ministry took a dim view of ground crew-improving aircraft. There were approved modification programs that went through proper channels with testing and documentation and official approval. What Lacey was suggesting was none of those things. It was guesswork and intuition backed by nothing except a mechanic's hunch that the boffins at Rolls-Royce had been overly conservative. But Walker had lost 2 wingmen in a fortnight to altitude disadvantage. He'd watched them die because they couldn't climb fast enough, couldn't reach the Germans who killed them from above. So when Lacey asked if anyone would object to a test modification on Walker's personal aircraft, the pilot's answer was immediate. Do it. And if it works, do it to every Spitfire in the squadron. Official channels had delivered nothing but excuses. Time to try something unofficial. The Rolls-Royce Merlin wasn't just an engine. It was 12 cylinders of precisely engineered controlled violence. At its heart, a single-stage, single-speed supercharger, a centrifugal compressor spinning at approximately 30,000 revolutions per minute, driven directly from the crankshaft through a gear train. Its job was brutally simple. Force more air into the cylinders than atmospheric pressure alone could provide. More air meant more oxygen. More oxygen meant more fuel could be burned. More fuel burning meant more power. The supercharger was the reason a 27L engine could produce over 1,400 horsepower instead of the mere 600 or so it would manage naturally, aspirated. Boost pressure measured how much additional pressure the supercharger created above normal atmospheric pressure. At sea level, atmospheric pressure sits at roughly 14.7 lb per square in. When the Merlin's boost gauge read P9 psi, the supercharger was cramming air into the intake manifold at 23.7 psi absolute, nearly 60% more than nature intended. That compressed air heated up dramatically during compression, which was why the Merlin used an intercooler to drop temperatures before the mixture entered the cylinders. Hot air was less dense, defeating the entire purpose of compression. The physics of combustion explained why Rolls-Royce set such strict limits. Inside each cylinder, the fuel-air mixture was supposed to burn in a controlled wavefront that spread smoothly from the spark plug, but compressed that mixture too much, heat it too much, and something catastrophic occurred. Detonation. Instead of burning smoothly, the entire mixture exploded simultaneously. The pressure spike was enormous, measured in milliseconds, but violent enough to punch holes through pistons or crack cylinder heads. Engineers call it knocking because that's what it sounded like, a metallic hammering that meant your engine was seconds from destruction. The Merlin 45 used 87-octane fuel, later upgraded to 100-octane as supplies improved. Octane rating measured fuel's resistance to detonation. Higher octane meant you could compress and heat the mixture more before it spontaneously exploded. With 100-octane fuel, Rolls-Royce calculated that plus a 9 psi represented a safe maximum with adequate margin for variations in fuel quality, engine wear, and manufacturing tolerances. Beyond that lay the detonation zone where engines died, but tolerances and margins were abstract concepts. Actual engines built by actual workers in actual factories varied. Some Merlin might detonate at plus 10 psi. Others might handle pulsing 12 psi without complaint. Rolls-Royce had no way to know which engine was which, and so they set one limit that protected the weakest examples. It was statistically sound engineering, but tactically frustrating. It meant many engines could safely produce more power than regulations allowed. Temperature complicated everything. A Merlin running at plus 9 psi on a cold Scottish morning operated under completely different thermal conditions than one running at Palin 9 psi in the Libyan desert at midday, where ambient temperatures hit 45 bar C. Hotter intake air meant higher cylinder temperatures, which meant greater detonation risk. The official limits didn't account for this variation because they couldn't. Conditions varied too much. So Rolls-Royce gave one number that had to work everywhere in every condition. The throttle gate physically prevented pilots from advancing the lever beyond the pulse 9 psi position. It was a simple mechanical stop, usually a bent piece of metal or a bolt position to block further movement. Removing or repositioning that stop took perhaps 10 minutes with basic tools. But doing so meant every time a pilot pushed the throttle forward in combat, he'd be gambling that his particular engine with its particular fuel at that particular temperature could handle boost pressures that Rolls-Royce insisted would destroy it. Lacey was proposing they make that gamble. Lacey waited until after the evening patrol had landed and the aircrew had disappeared for supper. Walker's Spitfire MKVB, serial number BR546, sat in its revetment, still ticking as the engine cooled. The modification itself was almost insultingly simple, which was perhaps why no one had attempted it before. It seemed too obvious, too crude to actually work. Lacey opened the cockpit access panel on the port side and traced the throttle cable assembly with his torch. The throttle gate was exactly where he expected it. A small metal stop welded to the quadrant that prevented the throttle lever from traveling past the pun's 9 psi position. It wasn't locked in place with anything sophisticated, just positioned and secured with safety wire. Lacey used wire cutters to snip the safety wire, then removed the stop entirely. He filed down the mounting point smooth, eliminating any chance it could be hastily replaced if someone noticed what he'd done. The whole process took 8 minutes, but removing the throttle gate only solved half the problem. The boost pressure control itself had a second safety mechanism, a relief valve in the induction system that would automatically vent excess pressure to prevent overboosting. This valve was calibrated to open at approximately pulsa 9.5 psi, dumping compressed air overboard to protect the engine. Lacey needed to either disable this valve or adjust its spring tension to allow higher pressures. He chose adjustment over removal. If he'd miscalculated catastrophically, the relief valve might still save the engine from complete destruction. The valve sat deep in the engine cowling, accessible only by removing several inspection panels. Lacey worked by torchlight, careful not to drop tools into the engine bay where they'd be impossible to retrieve. The valve used a spring-loaded mechanism with an adjustment nut. 3 full turns of that nut increased the spring tension enough that the valve wouldn't open until boost pressure reached approximately 112 psi. He was giving Walker an extra 3 lb of boost, roughly 20% more power than Rolls-Royce intended. The modification left no visible evidence unless someone specifically inspected the throttle quadrant or checked the relief valve adjustment. The boost gauge would still function normally. It would simply register numbers beyond the red line that pilots had been trained to avoid. Lacey repositioned the inspection panels, torqued the screws to specification, and stepped back. Walker's Spitfire looked identical to every other aircraft on the flight line. but it now had the potential to climb at a rate that would astound anyone who'd memorized the official performance figures. The technical risk was genuine. If the engine detonated, the piston failure would be immediate and violent. Connecting rods could punch through the crankcase, spraying oil and metal fragments into the engine compartment. In the worst case, the crankshaft itself could fracture, causing the propeller to separate from the aircraft. Walker would have seconds to recognize the failure and shut down the engine before fire consumed the entire airframe. And if that happened whilst he was engaged with enemy fighters, those seconds might not exist. Lacey also understood the career risk. If this modification resulted in catastrophic failure, the investigation would be thorough. They'd find his fingerprints on every component he'd touched. The court-martial would be swift. The verdict for ordained unauthorized modification, resulting in loss of aircraft and potentially loss of pilot. He'd be lucky to avoid prison, let alone remain in the RAF. But Walker had agreed to fly it, which meant the pilot considered enemy fighters more dangerous than an overboosted Merlin. The following morning, Lacey watched Walker climb into BR 546 for an early patrol. Neither man mentioned the modification to anyone else. If it worked, they'd know soon enough. If it failed, explanations wouldn't matter anyway. Walker completed his pre-flight checks with unusual thoroughness that morning, paying particular attention to the boost pressure gauge and engine temperature indicators. He'd agreed to this experiment, but agreement didn't eliminate anxiety. The Merlin fired normally, settling into its characteristic growl as he taxied to the runway. Nothing felt different. That was either reassuring or terrifying. He wasn't sure which. He lifted off at 06 on 20 hours and immediately began a climbing turn over the Mediterranean, heading out over the water where an engine failure wouldn't scatter wreckage across friendly positions. At 5,000 FT, still climbing at normal boost settings, everything remained perfectly ordinary. The engine temperature sat comfortably in the green. Oil pressure was steady. Head advanced the throttle gradually, watching the boost gauge needle creep past the red line for the first time in his career. Plus 10 psi, the Merlin didn't explode. Pulse 11 psi, still running smoothly. At plus 12 psi, he felt the difference, a surge of power that pressed him back into his seat more firmly than any regulation climb had ever managed. The rate of climb indicator told the story in stark mechanical terms. Where the Spitfire Mechi normally managed about toy 800 FT per minute at lower altitudes, Walker was seeing numbers approach 3,400 FT per minute. He wasn't just climbing faster, he was climbing at a rate that matched the published performance figures for the newer Spitfire McNie, an aircraft that wasn't even in widespread service yet. His modified MKV, supposedly obsolete in the Desert War, was suddenly performing like a fighter that wouldn't enter full production for another 6 months. At 15,000 FT, he leveled off and ran a series of tests. Full throttle at plus 2 psi produced noticeably higher airspeeds than the standard configuration. The engine temperatures climbed but remained within acceptable limits. The Libyan morning was still relatively cool, which helped. He tried a combat power climb from 15,000 to 20,000 FT, timing it carefully. 6 minutes and 40 seconds. The standard. MKV needed roughly 9 minutes for that same altitude gain. He'd just recovered nearly 2 minutes of climb time, which translated to approximately 2,000 FT of altitude advantage in any engagement. Walker pushed the throttle forward again and continued climbing. 22,000 FT, 24,000 FFT, the altitudes where BF-109s had dominated for months. At $26,000 FT, Heffenly eased back on the throttle, his oxygen mask hissing steadily. The engine had been running at prohibited boost pressures for 15 minutes without the slightest indication of distress. No unusual vibrations, no detonation, no catastrophic failure. Just smooth, powerful operation that delivered performance the manual insisted was impossible. He initiated a diving turn back towards Gambert, and somewhere over the coast spotted a pair of distant contrails at his altitude, likely German fighters heading back to base after their own morning patrol. Normally, he'd have ignored them. Engaging. When altitude neutral meant gambling that your turning ability could compensate for the 109's superior climb rate. But a day Walker had climb rate to spare. He advanced the throttle to plus 12 psi and pulled into a climbing turn that should have been impossible for a MKV. The German pilots apparently agreed because the contrails abruptly changed heading. They'd seen a Spitfire climbing, at a rate that violated everything they'd learned about RAF fighter performance over the past 6 months. Walker didn't pursue. He'd proven what needed proving. The modification worked. more than worked. It transformed. The Spitfire's combat effectiveness at exactly the altitudes where effectiveness mattered most. He landed at 0755 hours and taxied to dispersal, where Lacey was waiting with studied casualness that fooled nobody. Walker shut down the engine and climbed out, his face unreadable until he was close enough to speak quietly. "Every Spitfire in the squadron," Walker said. "Tonight, I want this done to every aircraft we've got." Lacey worked through the night with two other fitters he trusted, Sergeants Mills and Patterson. By dawn on 23 July 1942, 16 Spitfires and 145 Squadron carried the modification. They agreed on a cover story if anyone asked. Routine throttle cable maintenance. Technically true, just incomplete. The morning patrol launched with pilots who'd been briefed in whispers over breakfast. Push past the red line. Don't worry about the gauge. Trust the engine. The combat reports from that day's operations read like fiction. Flight Lieutenant Jeffrey Wellham engaged a BF-109F at 24,000 odd FT and actually outclimbed it during the fight, something he'd previously considered impossible. Pilot Officer David Cox pursued a German fighter that attempted to escape vertically and watched with satisfaction as his Spitfire matched the 109's climb rate all the way to $28,000 FT. The tactical equation had reversed overnight. German pilots who'd grown comfortable with their altitude superiority suddenly found Spitfires appearing above them, diving from positions that shouldn't have been attainable. Word spread the way rumors always spread on air bases, rapidly and unstoppably. By the end of July, mechanics from 601 Squadron appeared at 145 Squadron's dispersal, asking pointed questions about recent performance improvements. Lacey initially deflected, but the evidence was too obvious. Pilots talked. They compared climb rates and combat altitudes over drinks in the mess. Within a week, 601 Squadron's ground crew had implemented identical modifications, despite having no official authorization to do so. Then, 92 Squadron made the change. Then, 417 Squadron. The modifications propagated across Gamboot and neighboring airfields like a technical contagion. Each squadron's engineering officer faced the same calculation. They could follow regulations and watch their pilots die at an altitude disadvantage, or they could make an unauthorized modification that violated every maintenance protocol, but demonstrably saved lives. Most chose their pilots over their paperwork. Group Captain Hugo Rezi, station commander at Gamber, discovered what was happening in mid-August when he noticed identical climb performance being reported across multiple squadrons. He summoned the engineering officers and demanded explanations. The engineers, to their credit, didn't lie. They explained exactly what had been done and why. Vaz's response was carefully calculated. He couldn't officially approve modifications that directly contradicted Rolls-Royce technical specifications, but he also couldn't ignore combat results that showed dramatically improved performance. His solution was bureaucratic brilliance. He filed no reports about the modifications, issued no orders forbidding them, and made absolutely certain that higher headquarters remained unaware of what his squadrons were doing. Not everyone shared Vasey's pragmatism. At Techie Airfield in Malta, squadron leader Reginald Grant discovered the modification on several Spitfires and immediately ordered them reversed. Grant was a by-the-book officer who considered unauthorized modifications professionally unconscionable, regardless of their effectiveness. His mechanics complied with the order during daylight hours, then quietly re-implemented the changes after he'd retired for the evening. When pilots reported improved performance the next day, Grant assumed they were exaggerating or misremembering. His mechanics didn't enlighten him. The Air Ministry remained oblivious through August and into September. Combat reports showed improved performance, but headquarters attributed this to better tactics, increased pilot experience, or optimistic reporting. The possibility that dozens of squadrons had independently modified their aircraft in ways that violated fundamental engineering specifications simply didn't occur to anyone in London. Why would ground crew in North Africa know better than Rolls-Royces? Engineers? The illusion of ignorance shattered in late September, when a modified Spitfire suffered engine failure over Sicily and force landed in friendly territory. The pilot survived and the aircraft was recovered for assessment. The inspection revealed the throttle modification immediately. Within hours, a priority signal arrived at every RAF station in the Mediterranean theater. all unauthorized throttle. Modifications were to be immediately reversed, and any ground crew found implementing such changes would face court-martial. The order was politely ignored. Squadron engineering officers filed acknowledgement receipts, then made absolutely no changes to their aircraft. Pilots continued flying with boost pressures that officially didn't exist, and combat effectiveness remained dramatically improved. The Air Ministry's directive had collided with an uncomfortable truth. Nobody was willing to surrender a tactical advantage that was keeping pilots alive regardless of what London demanded. Air Commodore Raymond Kleshaw, commanding 204 Group, faced an impossible position. He had explicit orders to enforce the modification ban, but he also had combat statistics showing that squadrons with modified aircraft suffered significantly fewer losses in high-altitude engagements. His pilots trusted the modifications. His engineering. Officers vouched for them, and most damningly, after 2 months of widespread use, not a single engine had failed due to overboosting. Kleshaw quietly informed his superiors that enforcement would require time, then took as much time as bureaucratically possible. The Air Ministry's response was to dispatch a technical investigation team led by Squadron Leader James Tate, a Rolls-Royce liaison engineer who'd spent the war working on Merlin development. Tate arrived at Gamber in October 1942 with instructions to inspect modified engines, document the damage, and provide evidence for disciplinary proceedings. What he found instead created a problem that regulations couldn't solve. The engines were fine. Tate personally inspected 12 Merlin that had been operating at +2 psi for over 200 hours each. He removed cylinder heads, expecting to find cracked pistons, scored cylinder walls, and detonation damage. The components showed normal wear, consistent, with desert operations but no evidence of overstress. Bearings were within tolerance. Crankshafts showed no unusual fatigue. The engines that should have been destroyed were instead operating perfectly within specifications, just specifications that Rolls-Royce insisted didn't exist. The engineering team expanded their investigation, examining maintenance logs and interviewing Peel. They discovered that cylinder head temperatures at +12 psi remained within acceptable limits, provided pilots managed the mixture properly and didn't sustain maximum boost for extended periods. The desert's morning coolness actually helped. Operations typically occurred when ambient temperatures were lowest, giving thermal margins that partially offset the increased combustion pressures. Afternoon patrols showed higher temperatures, but pilots had learned to modulate their boost usage based on conditions. Tate's preliminary report filed on 18 October 1942 was a masterpiece of diplomatic language. He acknowledged that the modifications violated approved procedures. He noted that Rolls-Royce's published limits existed for sound engineering reasons, but he also couldn't deny the empirical evidence. Engines were reliably producing power levels that theory said they couldn't sustain. His recommendation avoided both endorsement and condemnation. Conduct controlled testing to establish whether official limits were excessively conservative under specific operational conditions. That recommendation ignited a bureaucratic firestorm. Rolls-Royce's engineering director argued that field modifications bypassed rigorous testing protocols designed to ensure safety. The Air Ministry's maintenance branch warned that tolerating unauthorized changes would undermine the entire technical authority structure. But Air Marshal Arthur Teeter, commanding RAF Middle East, cared about one statistic. His squadrons were now competitive with Bf-109s at combat altitudes for the first time since arriving in theater. The compromise emerged in November. The Air Ministry wouldn't officially approve the modifications, but they'd stop actively prosecuting them. Squadrons could continue operating with enhanced boost pressures under the unofficial designation of combat emergency power, a deliberately vague term that provided legal cover. Simultaneously, Rolls-Royce initiated urgent testing of Merlin 45 engines at higher boost settings to establish scientifically what ground crew in North Africa had already proven empirically, that safety margins had been far more conservative than necessary. The mechanics had been right. The Buffenshad had been cautious, and combat had forced everyone to acknowledge the difference. Rolls-Royce's testing program at Hucknall began in December 1942 with a goal of either validating the field modifications or conclusively demonstrating their danger. Engineers ran Merlin 45 engines at plus 112 psi for extended periods whilst monitoring every measurable parameter: cylinder head temperatures, exhaust gas temperatures, bearing temperatures, vibration characteristics, and fuel consumption rates. The results were simultaneously vindicating and embarrassing. The engines handled pleasant 12 psi without difficulty-provided fuel. Quality remained consistent, and pilots avoided sustained maximum power settings exceeding 5 minutes. By February 1943, Rolls-Royce issued revised technical specifications for the Merlin 45 series. Maximum continuous boost was officially raised to plus 112 psi for engines using 100-octane fuel, with plus 116 psi approved for emergency combat situations lasting up to 5 minutes. The new ratings acknowledged what North African mechanics had discovered months earlier. The original plus 9 psi limit had incorporated safety margins so conservative they'd actually hindered combat effectiveness. The revised specifications spread rapidly through RAF squadrons worldwide, and suddenly illegal modification became standard operating procedure. The Merlin 66 engine introduced in the Spitfire Minim from mid-1943 onwards incorporated design changes that assumed higher boost pressures from the outset. Strengthened connecting rods, revised piston crown designs, and improved bearing materials reflected lessons learned from monitoring the modified engines in combat. The Merlin 66 was rated at plus 118 psi for combat power and plus 125 psi for emergency war settings, pressures that would have been considered suicidal just 18 months earlier. Desert mechanics had fundamentally shifted Rolls-Royce's understanding of what their own engines could tolerate. The policy implications extended beyond boost pressures. The Air Ministry established new protocols for evaluating field modifications, acknowledging that combat units sometimes possessed operational insights that desk-bound engineers lacked. Technical orders began, including provisions for operational trials of unauthorized modifications that showed promise, creating official channels for innovations that previously would have resulted in court-martial. The rigid hierarchy between factory engineers and frontline mechanics softened slightly, though institutional resistance to field creativity remained substantial. Henry Lacey never received official recognition for initiating the modification. His name appears in no citations, no commendations, no post-war histories written by official sources. This was deliberate. Acknowledging Lacey meant acknowledging that an unauthorized modification had proven superior to approved procedures, a truth that made headquarters uncomfortable. He finished the war as a flight sergeant, was demobilized in 1946, and returned to civilian life repairing motorcycles in Lancashire. When asked about the war years, he'd mention working on Spitfires, but rarely elaborated. Johnny Walker survived the war with 12 confirmed victories and a Distinguished Flying Cross. He later wrote in his memoirs that the boost pressure modification saved his life at least 3 times by allowing him to outclimb German fighters in situations where a standard Spitfire would have been caught and destroyed. His memoirs mentioned engine modifications by ground crew, but carefully avoided specifics that might have caused trouble for surviving mechanics who'd participated in what was technically mass insubordination. The broader lesson resonated through post-war aircraft development. Engineers learned to distinguish between absolute physical limits and conservative operational limits, to build adjustment capability into systems rather than locking specifications rigidly, and to create formal mechanisms for combat feedback to influence design parameters. Modern fighter aircraft include multiple power settings with electronic limiters that can be overridden by pilots in combat situations. A direct philosophical descendant of that filed-down throttle gate in a Libyan revetment. The Spitfires that fought at El Alamein in October and November 1942 climbed to combat altitude on boost pressures that officially didn't exist, flown by pilots who trusted their mechanics more than they trusted technical manuals. The mechanics had been right. Sometimes the man with the spanner knows something the man with the slide rule doesn't.